So good day everyone. So welcome back again to my class. But before I proceed, I would like to request everybody to please like, share, comment, and subscribe to my channel. So happy learning! So today I will discussing factoring polynomial with difference of two squares, or that's. For our objectives, at the end of this lesson, you should be able to identify the expression that can be factored, determine the process of factoring polynomials with difference of two squares, show appreciation in factoring, and find factors of a given polynomials. But before that, let's have a short review. So let's find the factors of each expressions. So let's have a short recap on how to factor a polynomial with common monomial factor. For number 1, let's have 8a plus 10a squared. So for our solution, we need to find the GCF and the quotient of the given binomial so that we can get its factor form. So the GCF of 8a plus 10a squared is equals to 2a. And its quotient is equals to 4 plus 5a. So the factor form of 8a plus 10a squared is equals to 2a times quantity 4 plus 5a. Number 2, 16p raised to 4 plus 4p raised to 6. So solution. So the GCF of 16p raised to 4 plus 4p raised to 6 is equals to 4p raised to 4. The quotient of the 2 is equals to 4 plus p squared. So the factor form of 16p raised to 4 plus 4p raised to 6 is equals to 4p raised to 4 times quantity 4 plus p squared. Number 3, 32a raised to 6 plus 8ab minus 80b squared. So solution. So the GCF of 32a raised to 6 plus 8ab minus 80b squared is equals to 8. Its quotient is equals to 4a raised to 6 plus ab minus 10b squared. So the factor form of 32a raised to 6 plus ab minus 80b squared is equals to 8 times quantity 4a raised to 6 plus ab minus 10b squared. Number 4, 6x raised to 5y plus 2x minus 5y cubed. So solution. So let's find the GCF of the three terms, 6x raised to 5y, 2x, and negative 5y cubed. So as you can see, there is no common monomial factor between the three terms. So our answer is none. So if we don't have the GCF, we don't also have a quotient. So number 4 is not factorable. Number 5. So we have 4x raised to 5y minus 20x raised to 4yz minus 24x cubed y cubed plus 28x cubed yz. So solution. So let's find the GCF of the four terms. So our answer is 4x raised to 3y. And its quotient is equals to x squared minus 5xz minus 6y squared plus 7z. So its factor form is equals to 4x cubed y times quantity x squared minus 5xz minus 6y squared plus 7z. Okay, let's have letter B. Simplify the following expressions. So this time, let's have a short review about on how to multiply two binomials. So let's try. So number 1, quantity x plus y times quantity x minus y. So solution. So in multiplying two binomials, we can use the FOIL method or the distributive property. So it's either of the two. So let's try. So x times x is equals to x squared. X times negative y is equals to negative xy. X times y is equals to positive xy, and y times negative y is equals to negative y squared. So let's combine the similar terms. So we have xy. So negative xy plus positive xy is equals to 0. So our answer is equals to x squared minus y squared. Number 2, quantity 2a plus b times quantity 2a minus b. So, solution. So, let's multiply the two binomials using the distributive property. So, 2a times 2a is equals to 4a squared. 2a times negative b is equals to negative 2ab. 2a times b is equals to positive 2ab. And b times negative b is equals to negative b squared. So, combine similar terms. So, negative 2ab plus 2ab is equals to 0. So, our answer is equals to 4a squared minus b squared. Number 3, quantity c plus 4 times quantity c minus 4. So, solution. So, c times c is equals to c squared. C times negative 4 is equals to negative 4c. 4 times c is equals to positive 4c. And 4 times negative 4 is equals to negative 16. So, the middle term is equals to 0. So, therefore, our answer is equals to c squared minus 16. So, let's have number 4. Quantity 5q plus 3 times quantity 5q minus 3. So, solution. So, we can use the distributive property or the FOIL method. So, let's have 5q times 5q is equals to 25q squared. 5q times negative 3 is equals to negative 15q. 3 times 5q is equals to positive 15q. And 3 times negative 3 is equals to negative 9. So, the middle term is always equals to 0. So, the answer is 25q squared minus 9. And for the last number, we have quantity AB plus 5D times quantity AB minus 5D. So, solution. So, again, we can use the distributive property or the FOIL method. So, let's have AB times AB is equals to A squared B squared. AB times negative 5D is equals to negative 5ABD. 5D times AB is equals to positive 5ABD. And 5D times negative 5D is equals to negative 25D squared. So, the middle term is always equals to 0. Since negative 5ABD plus 5ABD is equals to 0. So, the answer is A squared B squared minus 25D squared. So, we almost done. We have a recap of factoring polynomial with common monomial factor, and we have the knowledge in multiplying two binomials or sum of difference of two terms. So let's proceed to our topic. So factoring out the difference of two squares is the reverse of multiplying a sum and difference of two terms. So examples. So when we multiply quantity 3a plus 2b to quantity 3a minus 2b, we will get an answer of 9a squared minus 4b squared. So if we want to get the factor of 9a squared minus 4b squared, so you will get an answer of quantity 3a plus 2b times quantity 3a minus 2b. So let's have another example. So when we multiply to quantity 5x plus y to quantity 5x minus y, so we'll have 25x squared minus y squared. And if you want to get the factor of 25x squared minus y squared, so we will get quantity 5x plus y times quantity 5x minus y. So remember, so these are all perfect squares numbers. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, so on and so forth. Steps in factoring polynomial with difference of two squares. So we will use the pattern quantity a squared minus b squared is equals to quantity a plus b times quantity a minus b. So first, notice that there are three requirements that must be met in order for us to be able to use this pattern. So number one, it must be a binomial, so have two terms. So both terms must be a perfect squares, so meaning that you can take the square root and they would come out evenly. And number three, there must be a subtraction, negative sign, so not addition, in between them. If these three requirements are met, then we can easily factor the binomial using the pattern. So simply write two parentheses, put a positive in one and a negative in the other, take the square root of the first and last term, and substitute the given square root of the first term in A and square root of the last term in B in the patterns. So let's have an examples. So number 1. Factor x squared minus 36. Solution. So check if it is satisfied the three requirements. Since it is yes, so we can now use the pattern quantity a plus b times quantity a minus b. So step 1, write two parentheses. So put a positive in one and a negative in the other. So step 2, take the square root of the first and last term. So our first term is the square root of x squared, which is equals to x. And our last term is 36, so we will get the square root of 36, which is equals to 6. Step 3, substitute the given square root of the first term and the last term in the pattern. So we have a equals to x and b equals to 6. So using the pattern, we will have quantity x plus 6 times quantity x minus 6. So it is the factor form of x squared minus 36. So checking. So let's check if x squared minus 36 has a factored form of x plus 6 times quantity x minus 6. So using the FOIL method or the distributive property, but we'll make it shortcut since the middle term, when we multiply the sum and difference of two terms, is always 0. So we will just multiply the first term and the last term. So x times x is equals to x squared, and 6 times negative 6 is equals to negative 36. So our answer is correct. Number 2, factor y squared minus 49. So solution. So check if it is satisfy the three requirements. Since it is yes, so we can use the pattern quantity a plus b times quantity a minus b. So step 1, write two parentheses. So put a positive in one and a negative in the other. So step 2, take the square root of the first and last term. So our first term is y squared, and our last term is 49. So the square root of y squared is equals to y. And the square root of the last term, which is 49, is equals to 7. So step 3, substitute the given square root of the first term and the last term in the pattern. So we have a equals to y and b equals to 7. So we have quantity y plus 7 times quantity y minus 7. So it is the factor form of y squared minus 49. So checking. So y squared minus 49 has a factored form of quantity y plus 7 times quantity y minus 7. So when we multiply sum and difference of two terms, we just simply multiply the first and the last terms. So y times y, we have y squared, and 7 times negative 7 is equals to negative 49. So check. Number 3, factor x raised to 4 minus x squared y squared. So solution. So again, check if it is satisfy the three requirements. Since it's yes, so we can use the pattern quantity a plus b times quantity a minus b. So step 1, so write two parentheses. Put a positive in one and a negative in the other. So step 2, take the square root of the first and last term. So our first term is x raised to 4, and our last term is x squared y squared. So the square root of x raised to 4 is equals to x squared, and the square root of x squared y squared is equals to xy. So step 3, substitute the given square root of the first term and last term in the pattern. So we have a equals to x squared and b equals to xy. So our answer is quantity x squared plus xy times quantity x squared minus xy. So it is the factor form of x raised to 4 minus x squared y squared. So checking. X raised to 4 minus x squared y squared has a factored form of quantity x squared plus xy times quantity x squared minus xy. So let's multiply the first term. So x squared times x squared equals x raised to 4, and we'll multiply the last term. So xy times negative xy, we have negative x squared y squared. So our answer is correct. Number 4. Factor pi b squared minus 5. So let's have the solution. So check if it is satisfy the three requirements. So yes, it is a binomial and it has a negative sign in between, but the numerical coefficient of the first and last term is not a perfect squares, which is the 5. So 5 is not a perfect square number. So meaning 5b squared minus 5 is not factorable. And for the last number, so factor 4x squared minus 25. So solution, so check if it is satisfy the three requirements. Since it is yes, so we can use the pattern quantity A plus B times quantity A minus B. So, step 1, write 2 parentheses. Put a positive in one and a negative in the other. Step 2, take the square root of the first and last term. So, our first term is 4x squared and our last term is 25. So, square root of 4x squared is equals to 2x. And square root of 25 is equals to 5. Step 3, substitute the given square root of the first term and the last term in the pattern. So we have a equals to x and b equals to 5. So therefore, our answer is equals to quantity 2x plus 5 times quantity 2x minus 5. So that is the factor form of 4x squared minus 25. So checking. So 4x squared minus 25 has a factored form of quantity 2x plus 5 times quantity 2x minus 5. So multiply the first term. So 2x times 2x is 4x squared. And multiply the last term. So 5 times negative 5 is equals to negative 25. So our answer is correct. So now, ready your ballpen and paper. So let's try this activity. So factor completely. So show your solutions. And for your assignment, so another one, factor the following expressions. So if this video is a great help to you, then please don't forget to like, share, comment, subscribe to my channel. So thank you.